You know that feeling, right? You're working with one of these super powerful AIs and it's brilliant until it isn't. It just gets confused or drifts off topic or, completely loses the plot. Well, today we're going to dive into a really fascinating new way of thinking about this, a kind of speculative mini textbook for AI. And it suggests the problem isn't about more power, it's about a better blueprint. Okay, let's get into it. So here's our roadmap. We're going to start with what's actually wrong with AI architecture right now. Then we'll introduce this really cool new concept called the bounded observer. From there, we'll unpack a 5-part blueprint for what intelligence could look like, look at the engine that drives it, and finally, see how this all might lead to building AI we can actually trust.
Yeah, this phrase, it just nails it, doesn't it? We've all seen this happen. An AI kicks off a task, it's all going great, but then somewhere down the line, it gets tangled up in its own thoughts, forgets the main goal, and the whole plan just unravels. It's a really common and honestly a super frustrating problem. So that brings us to the real million-dollar question. Why does this keep happening? Is it just a bug we need to patch? Do we need more data? Or is it something way deeper? Something kind of fundamental about how we're even putting these systems together in the first place? This whole explainer is really about looking at that question through a brand new lens. And that leads us right into the first big idea. The central argument here is that just making our models bigger and bigger, the whole scale is all you need thing, it's not going to fix these deep, weird problems. The issue isn't a lack of horsepower, it's the lack of an architectural grammar. And this visual just lays it all out perfectly. Over on the left, you've got the way we do things now, the giant monolithic big model. It can talk a good game for sure, but there's not much internal structure. It's kind of just one big blob. But on the right, you see a totally different approach, a structured, multi-part system that has explicit controls built in. That's what helps it stay on track and not fall apart when things change. So, what this really boils down to is this. We've gotten unbelievably good at building these massive computational engines. I mean, they're amazing. But what we're missing is the rulebook, the grammar to actually organize all that power in a way that's reliable and that we can actually inspect and understand. So how do we start to fix this? Well, the whole thing starts with a pretty big shift in perspective. Instead of thinking about AI as this all-knowing entity like a god in a box, we need to start thinking of it as a bounded observer, something with real defined limits. Now, check this out, because this diagram is really the key to the whole thing. You've got this overwhelming flood of information coming in from the world, but the bounded observer, our AI, it can't process everything. It can only pull out a certain amount of stable, usable structure. And everything else, all the noise, the ambiguity, the contradictions, that becomes what this framework calls a governable residual. And that term, governable residual, is so important. It's all the messy stuff that doesn't fit neatly into a box. I kind of think of it like a ship's captain in a huge storm. The storm is the residual. It's chaotic, you can't predict it, and you sure can't just wish it away. The captain's job isn't to stop the storm, it's to govern the ship through the storm. And that's the goal here. Don't pretend the mess doesn't exist. You have to acknowledge it, track it, and manage it. This slide kind of puts that idea into a simple formula. It's saying any snapshot of the world can be broken down into 2 pieces. S, the solid structure you can actually understand and use, and H, all the leftover unpredictable stuff. So the whole art of building a good AI isn't about getting rid of H, because you can't. It's about getting as much S as you can while being really smart and honest about how you handle the H that's left over. Okay, so that's the big theory. But how in the world do you actually build something like that? Well, this is where we get to the practical part, the blueprint, which is called the master formula of structured intelligence. And here it is, the whole shebang in one diagram. The argument is that any intelligent system that's going to be useful in the real world where things are messy and goals change absolutely needs to have these 5 different jobs running in coordination. So let's just quickly walk through these. First, you've got structure maintenance. That's basically holding on to the goal, remembering what you're trying to do. Second is flow navigation. That's dealing with all the new stuff coming at you. Third, and this one's huge, is adjudication, judging what to do next. Fourth is scale selection, picking the right zoom level. Are we thinking seconds or years? And last, trace preservation, keeping a record of why you did what you did. Let's just double click on adjudication for a second, because this one is absolutely critical. Think of it as the system's conscience, or its governor.
A regular language model can spit out a million possible things to say next. The adjudication function is what looks at all those options and says, yeah, but which ones are actually viable? Which ones actually make sense and get us closer to our real goal? It's the filter that separates random generation from actual intelligence.
All right, let's pop the hood on this blueprint and look at the engine that really makes it all run. And it all comes down to this constant push and pull, this critical tension between structure and flow. Wow, I mean, this is just such a perfect way to visualize it. On one side, you've got structure, which they call the body. That's the stable part, the plan, the thing you're holding on to. And on the other side, you have flow, the soul. That's the active, dynamic part, the pressure to adapt and change. Any healthy, intelligent system has to have both. And, if you get that balance wrong, the whole system just collapses. If you have too much structure, you get a system that's super rigid and brittle. It just can't adapt when things change. But if you have too much flow, you get that drifty, hallucinatory system we were talking about, one that can't hold on to a goal to save its life. Okay, I know this quote sounds a little academic, but stick with me because the idea is actually pretty simple and really important. Complete rationality, or what we just call being smart, isn't about picking one side. It's about coupling them. You need the density side coherence, that's your solid, stable foundation, and you have to connect it with phase side path navigation, your ability to find a way through the chaos. You need the Mac and the navigator. So after all this theory, all these diagrams, why does any of this really matter? What's the end game here? Well, it's all about building AI we can finally count on, what this whole framework calls governable AI. And this right here is the crucial shift in our entire mission. For years, we've been obsessed with building fluent predictors, systems that are just really good at guessing the next word. The goal, this argues, should be to build governable runtimes, systems that behave in a predictable, reliable way that we can actually direct and audit. So what does that actually get us in the real world? Well, a governable AI is one that's reliable, even when things get weird. It's auditable because it actually keeps a record of its decisions. It's honest about what it doesn't know, and because of all that, it's way less likely to have those bizarre hallucinations that make today's systems feel so untrustworthy. And that's really the thought I want to leave you with. For so long, the story of AI has just been about getting bigger. More data, more compute, more power. But maybe, just maybe, the next giant leap forward isn't going to come from a bigger engine, but from finally inventing the architectural grammar we need to actually steer it.